Hello, this is Ms. McCahan, and in this video we're going to discuss functions and their graphs. Please remember that if you need to stop and write things down, to pause the video, or you can do that throughout as you need to. So first let's talk about some vocabulary. First, a relation. All that is just a pairing of input and output values. Another way to say that, you could say it's a pairing of two events. For example, if I wanted to see if age and height had any kind of relationship, I'm just relating those two things together. So that's all a relation is. Whenever we collect data, that's what we're doing. We're trying to record two different things and see if they have a relationship. All right, so let's talk about domain. Domain is simply the input values. Okay, another way of saying that are x values. If we have x coordinates and y coordinates, the domain are the x values. Another way to say that also is the dependent variable. Independent variable. Or it's just the numbers that we would plug into the equation. The range is just the opposite. The range are the output values. So those are the y values. So if I have x and y coordinates, the y values are the range. Okay. It's also going to be linked to the dependent variable. Finally, we have function. Function is just a relation, but it has to have a specific kind of relation. So it's a relation where each input has exactly one output. Okay, so each x value only matches up to one y value. Or, for example, if I plug in a value, I should only get one single answer. I shouldn't be able to plug in the number 3 and then get two different answers for when I plug in number 3. So let's talk about now ways to represent relations. We can relate them with ordered pairs. We can do that with a table. We can do that with a graph or with a mapping diagram. Now, I know you guys are familiar with ordered pairs, tables, and graphs. The mapping might be a little bit different, but you've probably seen these in Algebra 1. What I want you to notice about all of these is that I have the input -2 has two different outputs. It has +2 and -2. So that makes this not a function. And these are the same values all throughout. So you can see in the table that's happening as well. Same thing on the graph. These have two different y values. Okay. And then over here in the diagram, you can see that -2 is branching off in two separate places. Okay. Also notice in this diagram that it's okay that 0 is mapping to 1 and 3 is also matching to 1. This is okay. All right. This part is not okay. So all of these are not functions. Okay. Another way to say that with the coordinate pairs, it's not okay to have x's repeated, but it is okay to have the ones repeated. Okay, same thing in the table. So if we look at these two examples, this first example, all of these inputs only branch to one output. So this would be a function. Whereas over here, this is okay, this one's okay, but 2 is mapping to 2 separate answers, 2 different outputs. So this is not a function. So let's look at this one. Here we have ordered pairs. So remember in ordered pairs I said it's not okay for the x values to be repeated. So look at the x values here. I have -5, -3, so far so good, 0, but oh, here I have 0 again, and here I have 0 again. So these x values are repeated, and that is not okay. So this would be not a function. If you're having trouble with that, you can also put it in table value. So you could say that these are the x values, these are the y values. This is -5, 2, -3, -1, 0, 0, 0, 2, and then 0, 5. Okay, so you can see right away that all of these have different outputs. Okay, so when you say this is not a function and it says to explain, all you have to say is it's not a function because 0 has 3 different outputs. If it was a function, we could say, yes, it is a function because each input has only one output. So let's talk about the graphs for a minute. We have this special test that we can do to see if it's a function. It's called the vertical line test. And all that says is a relation is a function if and only if no vertical line, so it has to be a vertical line, it can't just be any line, if that intersects the graph of the relation at more than 1 point. So you can see here that this vertical line, if I were to try to move that around, it only crosses the graph once, no matter where I move it. So here, it's only crossing right there. If I move it here, then it's only crossing the graph right here. So each time I move it, it's only crossing the graph one time. So that's why that one is a function. Whereas over here, this line is crossing the graph here and here. So that's more than once. That means that doesn't pass the vertical line test. So we would say, yes, this is a function. It passes the vertical line test. Here, over here, we would say no, and it does not pass the vertical line test. And you can abbreviate with VLT. So that's what we need you to know for functions and their graphs.